Hello, I'm Doug Sarr. I'm helping lead teach the ARA course for CASE. One of the things that we wanted to do to help you on-ramp into the program and to help with your software and hardware tools was to give a little brief tutorial on the Arduino system to help prioritize the classroom experience. We want this to be as Chromebook friendly as possible. So one of the things we tried to do was to incorporate the Arduino Cloud. The quick summary of Arduino Cloud is it's a program from I forget what the exact organization is, but basically there's a nonprofit organization that creates this little board called an Arduino. It's open source, so it tends to be very friendly in the maker community, tends to be very supported in education and learning, and it tends to have a lot of options because people develop more devices and sensors for it the longer it's around. So this Arduino product, it would look something like this, and so I'm using Tinkercad to show this. And the Arduino board is a small little board that has a bunch of inputs, a bunch of outputs. You can put power through it, but basically, to sum it up, it's a microcontroller that's pretty affordable. You can get them for anywhere between 10 to 15 bucks. They come in a lot of different shapes and sizes and different configurations. This one here in particular is the Uno. This is kind of the really basic SKU. As a whole, it's very functional for doing a lot of activities and projects on sensors and hardware. Not as robust as some other options. Most of the base Arduinos won't have example like Wi-Fi connections and things like that, but there are plenty of other devices out there that support that. The quick little 2-minute tour of the Arduino board, just so that we understand what the future code will look like when we get to that. Arduino board here. We have our pins on the top here. These are digital pins, so digital, yes or no, true or false, 1 or 2 or 1 or 0. Those are the pins that we'll plug into for a lot of our signals to send a signal to the board to make it behave. Either it's going to read a signal or it's going to send out a signal. GND is always ground. We use that quite a bit. This PWM, you'll see this little tilde, I believe is what we call this, between 11 and 10 and 9 and 6, 5 and 3. Those are all going to have a PWM signal, and PWM is basically an artificial analog signal. To summarize that, some of our lessons will cover that in a little bit more detail. But if you ever are looking for a digital input that is asking for a range of values, then that's usually a PWM. On the bottom here we have a full analog rail, 0 to 5. That's going to be more for things like digital displays and some other more advanced circuitry or sensors. And so that's in this bottom portion. And then we have our power rail. Some things to really note is you have your 3 volt, your 5 volt. Majority of sensors are going to be 5 volt. So make sure you use that source unless it's otherwise noted. And then you have a couple of grounds. On the right side here, we have a breadboard. The breadboard is a very simplified prototyping tool that helps us organize and track all of our wires and connections when making something in a more quick fashion. I drew these green lines here to represent, so if you have a ground line, in this case, like so if I take a wire here, and I'm using Tinkercad to connect these together, so a ground line over to the ground portion here. The green beans, those are all the dots that are connected in that circuit so far. This will also behave the exact same way if I put in a 5 volt signal. So if I grab, I can go change my color here to just red, make it a little more clear, and then, and I'll change this back to black for my next wire here. Ground is going across, 5 volts going over here. So now that rail is completely connected over that side. So the breadboard itself has you have a rail here with the negative and the positive signal going through. And down here you notice that the green lines are going vertically. And that is to where we're going to stick our pin wires. And so these pin wires can you have a pin that goes from port 9 to your signal. So then you would go from 9 over to this point. And then from there, anything that's plugged onto this one section will be connected with that in the circuit. So go from the 9 over to the 1. Maybe you have another wire that is going from here to somewhere else, and so then the circuit would keep going along that path. So if you needed something to break it, or you're connecting something in between, that's where it would talk from one to the other. It does not reach across this little channel in the middle. You do have to put an extra pin across that if you're going, or a wire across that, or a jumper across that if you're going to connect it. So a really simplified version of this, using this breadboard and this illustration here for a circuit, is I have a resistor here. Common resistor for an LED is 220, and then I can put this resistor on the rail from point to point. I can have then I'll have the resistor plugged in, and so if I was plugging this in real life, which we will have plenty of opportunities to do so, I would go from the 5 volt, and in this case I could go straight into the system because this is only going to have one component tied to it, so I can go from here to here. Then I can get my next wire, color really doesn't matter, but it's just helpful for organization, and go from here to here and hit ground. Now if I'm following through on this signal, the 5 volts going across into the breadboard, sharing that signal with this resistor. The resistor carries it over to this side, goes to the LED, should go through the LED, back around, and then to the ground source. Now in Tinkercad, you can go ahead and click Start Simulation. It should run it. You see the LED started to glow. It means it's working. There's a lot of other components and things like that involved, but that's kind of the gist of the wiring, and that's going to make sense when we get to the cloud.